Okay, first I'd like to visualize the problem that we are dealing with. So 90% of the world's data was created in the last 2 years, and we now create over 2.5 quintillion bytes of data every day. 80% of the data collected by organizations is unstructured. And it's that unstructured data that we focus on, because in order for our systems, the things that we rely on to run our businesses, in order for those systems to understand and process this data, it needs to be made structured. To put this in some context, systems create structured data. People, that's you and me, we create unstructured data. It's often descriptive and unpredictable. Now, unstructured data might include video, audio. What we focus on is textual information, and specifically the stuff that is defined, certainly in this diagram you see in front of it, so it's offline. And that includes channels such as post, paper, fax, email, the attachments that come with email, social media, and of course there are lots of other electronic data streams that move information around. And this stuff flows into organizations every day. The unstructured and varied nature of it makes it very labor intensive. And of course, if you have people involved in dealing with it, it's prone to errors and delays. And it's a significant barrier to things like good customer service, and especially to operational efficiencies. Now, the stuff that flows in every day will be familiar to a lot of people. It takes the form of correspondence, inquiries, complaints, claims, and these are some of the most complex patterns that we see. There also includes semi-structured information, and it's no less complicated for the software to deal with. And it includes invoices, orders, applications. Now, this semi-structured and relatively simple information still requires human intervention. And machine learning is the only approach that can deal with it, because the software needs to learn the pattern of data. It's far too varied to rely on things like keywords and templates in order to solve the problem. So here's a simple view of how this data is processed through our InStream platform. Now, the InStream platform operates as a service. It consumes content from post, paper, fax, email, the attachments that come with email, social media, lots of other electronic data streams. And the first step is to capture and consume this information and to normalize it. So, for example, if something comes in on a piece of paper, it's got to be scanned, obviously, and we take that scanned image, we OCR it, and we turn it into digital information so that we can continue the process. And we can consume that information in lots of different ways. We can either go and fetch it or receive it. That bit of it is really open and flexible. But the first really intelligent steps start being made when InStream is trying to understand the meaning and intent of the content. Now, in many ways, this is to try and understand what is the customer actually saying. And it doesn't necessarily have any interest in how angry you are, but it wants to get to the point, what is it that you're actually saying? The second step, once that is understood, is to recognize and extract key data from within that content, wherever it may be. And this data is essential for the rest of the process. From here on, once we've extracted that data, we're working with structured information. So we can do many things with it, including verifying and enriching it with other sources of information, and then uploading it to other line of business systems to continue that process. What we're also able to do as a result of understanding what the customer's saying, understanding who the customer is, maybe what they're talking about, like maybe even complaining or claiming about something, we're able to respond to the originator with a very personal and very appropriate response. So in simple terms, we're taking in unstructured, varied content and making it not just structured, but guaranteed perfect structured, so that other line of business systems can continue that process. But at the heart of InStream is its ability to learn, and it learns through the natural consequence of processing this information. So in this diagram, you'll see some characters at the bottom, and they are the people that are interacting with the process. They're not doing any coding or development or configuration. They're simply answering questions that are presented to them in exactly the same way they would have done before the technology was implemented. So wherever the software is not confident, it presents it to an operator. The operator answers the question, points and clicks at where information is, and the software is building up those references in order to better understand what the content means, where the information is, so it minimizes the dependence on people thereafter. So one of the things that the way that we're able to learn is through training data. Now, training data in real life is often the data that customers have already processed, and they accumulate this in huge volumes. And we typically call it historical data. In the world of machine learning, it's often called just training data. Now, InStream can gain great advantage from this learning. However, what makes InStream unique is its ability to learn what we call day forward. So it's a bit like hiring a new member of staff, let's assume they're a school leaver. They know nothing about your business, and they'll ask questions, and with every answer, they gain confidence until they start suggesting what might be the answer, and you either confirm or not. Well, that's exactly how InStream is working. Okay, so let me introduce you to Virgin Trains, who are one of our customers. They're very typical of the sort of organization that we deal with, in that they are large, they're ambitious, but they deal with a demanding consumer. And this is a great example of a customer that has applied InStream to achieve better customer experience in handling correspondence, complaints, compensation claims, and general inquiries. So the challenge that this organization had, and it is not uncommon, is that they had hundreds of unstructured contacts every day, and they were coming in by email and also through their website, so they were web inquiries. But actually, regardless of the fact that they were web inquiries, they all funneled into an email channel. Now, aside from the average and normal day-to-day stuff that came in, there was significantly more during periods of surge. And these surges were created when there were issues on the network. A train being delayed has a knock-on effect, and all of a sudden you have many, many people who are making contact and either claiming or complaining, and these surges need to be dealt with in exactly the same way as you would deal with any contact on a normal day. So there was a huge amount of stress on people to deal with backlogs. Customer service was impacted because service advisors were buried under the weight of dealing with repetitive tasks. They were reading emails and inquiries to understand what the customer's saying. So InStream receives all of these emails and web inquiries and understands what they are saying. It recognizes the key data within the content, and it is able to accelerate that process appropriately. So in a nutshell, it was able to receive a contact, understand what the customer is saying, recognize the data that's required from within that content in order to go and check, has this customer complained before? Was this passenger's train late? If it was late, why it was late? And be able to respond back to the customer appropriately. So that gives a great experience. It gives time for the service advisors to go and investigate priority cases if they require human intervention. So the outcome is that just to be able to understand what the customer is saying, the reduction in manual effort in that step alone was reduced by 85%. In surges, there were no additional staff required, and that's regardless of the demand and surges that were placed on the team. And in order to implement the system, it learned over a period of 4 to 5 weeks, but it was helped by the fact that there was a huge amount of historical data to access and learn from. The other thing was that certainly with this train operating company is they were the first to implement a fully automated compensation payment system to passengers. So if you've travelled on this particular train operating company and you booked an advance ticket and your train is late by more than 30 minutes, you are now automatically compensated without even contacting the train operating company. So there's a consistent increase in the Net Promoter Score and no additional staff to deal with that increase in contacts, even in that surge. So these are the sort of results that we see visualized, not just in the example I've just given, but in many other organizations. Sudden surges in contacts, yet the number of people required to deal with them remains consistent and the SLA is always achieved. What we're also seeing here is there is a consistent growth in the contacts, and yet at the same time, it takes less time to resolve each case, which means better customer service is delivered. The outcomes are relatively straightforward. Now, what you may see from this is that whilst there is a reduction in cost, because you don't need as many people dealing with this number of transactions, that is not the primary focus, certainly not of the organizations that we are dealing with. Their primary objective is to deliver better customer experience, to have the people employed in those teams doing stuff that they were originally employed to do and not getting buried down in mundane, repetitive tasks that can be carried out by the machine. So InStream achieves some significant benefits for many organizations in customer service operations, claims and compensation processing, finance and accounting, sales order processing. And here are just some of the numbers that will hopefully speak for themselves.
Thank you, Andrew. That was a lovely talk. For those who don't know, can you please clarify what OCR stands for?
Okay, so to put OCR in context and explain a little bit about what OCR means, OCR stands for Optical Character Recognition. It's sometimes spoken about intelligent character recognition. It's all rolled into the same terminology, but in reality, what OCR achieves, it takes a scanned image, which might be a picture or a scanned document that has been captured through a scanner, and it turns the image of a character into a machine-readable character. So rather than being able to process a picture of an ABC, it actually turns that ABC image into a ABC characters. Now, what a lot of people believe is that OCR is the solution, where in fact it is merely a part of the process. So it is essential in turning an image into a machine-readable character. So you end up with words that the computer can understand. However, that doesn't mean that you understand what the customer is saying. It merely turns the information into a format that the rest of the process can then take forward and understand meaning and intent and recognize and extract the key data from.
Okay, thank you for answering that. Would you mind telling us a little bit more about machine learning, please?
Right. So machine learning, we're onto a very broad subject now. But let me just repeat what I said earlier on. So systems typically create structured data, whereas people, that's you and I, we create unstructured data, and it's this unstructured data that's created by people that makes up a significant part of what flows into an organization every day. So InStream is designed to process this data through the application of algorithms that include artificial intelligence and machine learning. Now, I use the word artificial intelligence, which is an even broader subject. But to answer your question, machine learning is a subset of artificial intelligence, and it provides computers with the ability to learn without being explicitly programmed. Now, this ability to learn, which is essential to effectively processing unstructured, often descriptive content, due to the variations that occur. And this unstructured data takes many forms, and InStream is designed to handle data that flows in through offline channels like post, paper, fax, email, social media, etc., etc. But what it's not designed to do currently is to handle conversations and chat and video and audio and stuff like that. And what I'm trying to say here is there is machine learning that is applied to lots of different ways to deal with lots of different problems. We're in the offline bit, but there are other types of machine learning that deals with that deal with all those other different types.
Thank you very much again, Andrew. For those of you who are interested, we have part 1 to this webcast given by Hannah D, and that can be found on our AI Accelerator webpage on the BCS Women website. Thank you all. Bye-bye.